Good morning, everyone. We will get started in just 1 minute. I'm glad everyone is able to participate, and we will kick off the session in just a second. Let me pull up my slides. So good morning, good afternoon, and good evening, and welcome to the first annual BioPACIFIC MIP Summer School. My name is Alaniz, and I'm the director of the new NSF BioPACIFIC MIP, which is located here at UC Santa Barbara and UC Los Angeles. And before we get started, I just wanted to take care of a couple of housekeeping items. And so, as we all know, the summer school will be on a webinar platform. And so if you want to ask questions, you can use the Q&A function at the bottom of your slides, and then we'll address all those questions at the end of each session. And then also, many of you will know that we have a series of closed professional development programs that are available to select graduate students that are participating. If you're participating in those, you'll receive a separate Zoom link and instructions, and you should have already received that via email. And then lastly, we know that this Zoom format, right, we really wish it was all in person. I think we all can recognize how vital it is and how important it is to have these in-person meetings. But what we wanted to do to try to make this as interactive as possible is we have set up a Slack channel. And for those of you who don't know, this is a messaging app that will allow us, we hope, to communicate with all the participants. Please leverage Slack to use this to connect with your fellow colleagues, to meet new people, to network, as well as to ask questions to leadership and everyone else within BioPACIFIC MIP. And then last but not least is probably the most important announcement is I really want to give a shout out to Debbie and the entire BioPACIFIC MIP operations team. Over the last month, they have done a tremendous job putting together what will be a really outstanding next 4 days of a summer school. And so I want to give them the big virtual round of applause and thank them all for their help, and all the speakers really for joining us in the next 4 days. It's greatly appreciated. And so now it's my opportunity to introduce Professor Heather Maynard. Professor Maynard is the co-director of BioPACIFIC MIP, and she will lead us off and tell us more specifically about BioPACIFIC MIP, what makes a MIP unique, as well as what we hope you guys will gain over the next 4 days. So Heather, I'll turn it over to you.
Great, thanks, Javier. Javier, do you mind? I think we're seeing the wrong view. We're seeing, not seeing presenter mode.
Let me swap that.
Yeah, that's perfect. Great. Thank you so much. Okay, so welcome everyone. Good morning, afternoon, potentially evening, depending where you are. I'm so glad you could come to the summer school. As Javier mentioned, I'm Heather Maynard. I'm not only co-director, I'm also physically located at UCLA. And so I'm going to tell you a little bit about the MIP. So the BioPACIFIC MIP, or the Materials Innovation Platform, is funded by the National Science Foundation, so the Division of Materials Research, at the level of $23.7 million over 5 years. So MIPS are a mid-scale infrastructure program with specific and unique goals, and you'll learn more about those over the week. And we're really excited about this center because it's a first sort of user facility in the United States that combines automation, high throughput experimentation, and synthetic biology and material synthesis. The ultimate goal, of course, is to discover and develop new biomaterials and bio-derived polymers and to push the edge of that field considerably. Next slide, please, Javier. So, if you can go back one, maybe.
I think that's right.
Okay, so I just want to mention a little bit about the BioPACIFIC, how it's actually a knowledge hub. So we envision that this is a place where you can come for not only instrumentation expertise, but knowledge sharing and actual samples that will be available, strains and monomers and polymers, et cetera, that you can use in your research. And don't forget about computational design and understanding. So we're going to hear all about that over this week. Next slide, please. So BioPACIFIC really will exploit synthetic biology, which is typically slow and serial, and making it high throughput and automated. So it can you can quickly go through this build, test, learn, design cycle to prepare bio-derived monomer libraries. We can envision that this can be new, highly functional potential chiral molecules, monomers that could be not available elsewhere, or you can generate known molecules, but now from sustainable sources. So we're excited about both of those avenues. And then these libraries can be subjected to automated high throughput polymerization to quickly yield novel polymers and biomaterials, and a whole slew of really exciting characterization techniques and computational techniques. Javier, next slide, please. Okay, so here's the leadership team. You'll hear from everyone on this page over the week. And so as you can see from the list here, that we have diverse expertise covering the biomaterials realm space, from synthetic biology to synthesis to characterization to computation, and also education and outreach. Next slide, please. And also, BioPACIFIC's goals are to develop next generation tools, unique, one-of-a-kind instrumentation and computation, enabling this exciting research that we're talking about. And at the same time, it's a user facility. So in fact, 50% of the MIP time is for external use outside of UCSB and UCLA user projects. And so the user facility there necessarily then involves dedicated and expert staff, and here are their names. And you're going to have a chance to talk with many of them. For example, there's office hours available if you want to understand the equipment that they're using and how to use it later on this week. Okay, thanks. So now with the overview complete, let's look at the summer school. So you're going to hear from experts from both academia and industry. They're going to be talking about their research in biomaterials, their company's research. And for that, what we really hope that you learn, or what the outcome is for you. Well, first of all, we of course want you to learn about their exciting research. It's cutting edge, the people that we have coming to the school and teaching. But we really hope that it sparks ideas for your own research. And not only that, that you think, wow, here's something that I've never thought of before, can create new avenues or new connections for new project ideas. And then also, at the same time, we really hope that you understand the capabilities of the BioPACIFIC MIP. So not only determining which MIP tools would enhance your own projects, current projects, but then think about, well, hey, if I use that tool, I might be able to take my research into this other direction. And then finally, we have a lot of professional development threaded throughout. And so we'd like you to gain knowledge about this. We've been talking about this build, test, learn, design cycle, and also intellectual property. And you'll have a lot of chances to augment your network. And so please do that. And then also to understand the IDPs, or how to augment the IDPs. If you're not familiar with IDPs, or individual development plans, and how you can maximize those, as well as careers in biomaterials. So that's what we're going to pack into this 1 week for you guys. And we hope that you have a really good time. Next slide, please. Yep, so here's the overview of just today. And so you can see we're starting off here, and then we'll hear about automated material synthesis and synthetic biology and so on throughout the day, ending up with sort of a STEM speed dating networking type of session. And the next slide. And then, of course, you can see if you ever are questioning when is what happening, what time, of course, there's the webpage, and you're welcome to go there to see the speakers and the agenda and so on. Okay, Javier, I turn it back over to you.
Thanks, Heather. And so now what we wanted to do is just give you guys a little bit of a flavor of, what is a MIP and what makes it unique. This is a new type of center that was established by the National Science Foundation in 2016. And so as Heather mentioned, this is a mid-scale infrastructure program that really sits under the NSF Division of Materials Research. And it has 4 main pillars that really encompass not only the user facility, but also the mission. And so one of the main missions is really tool development, as Heather mentioned. And so you'll hear a lot about how do we set up a center to develop the next generation experimental and computational tools so that the entire community, right, not just folks at UC Santa Barbara and UCLA, can really leverage these tools to advance their materials research. This is a user facility. We'll talk a little bit more about how you can become a user. And it also has in-house researchers, right? And so this is led by dedicated staff scientists but it also has a number, right, of around 20 research scientists that are in-house at UC Santa Barbara and UCLA, really that are driving this idea of leveraging synthetic biology with material research. And then, as Heather has mentioned, strung throughout and really trying to weave this in is a lot of workforce development. How do we train the next generation workforce in not only tool development, but also how do you become someone who is transitioning from, and you're going to hear a lot about this throughout the week, going from simple benchtop setup to high throughput automation, and how do we transition our thinking of how we set up those types of experiments. Some of the key things that we want to mention is that once we hit steady state, so today is actually day one of year 2, right? So we kicked off exactly 1 year ago. And so once we hit steady state, which we believe would be around year 3, 50% of the time would be dedicated to external users, right? So this really is part of the community, and we really want everyone to have a stake in that. And so how do you do that, right? So we want to just very quickly walk through some of the basics of becoming a user. And you'll hear more about this, but really we've set up a 4-step process to become a user. This is a proposal-based process. This is on rolling submission. There's 2 types of proposals. So you could either have a service request, but we really are pushing and favoring in-person research where you come and use our facility. We recommend that you discuss any of your proposal ideas with our technical team or our directors, and we actually have office hours set up during this week so that you can start that process. But if you don't have the opportunity, you can certainly use this contact request form, which is on our website, to start that process. The whole proposal is done in a portal on our website, and you can find more information on that website. But probably the most important information that I want to convey is that this is an NSF-funded project. And so what that means is that all proposals that are awarded, you are not charged time for the technical staff, supplies, or for equipment that is acquired from this MIP award. And so you'll hear a lot more about what those MIP tools are in a second, but I think this is really one of the advantages. If you want to keep your research proprietary, we have structures in place to do that. And again, we can talk about this in more detail offline as needed. Once you submit your proposal, this goes through a feasibility review. Really, this is just an internal review to make sure that your proposal can be executed on the equipment, that the staffing is available at the time, and that we have the materials and resources available to execute the proposed research. Once that process is cleared, it goes out to external community. Many of you will be asked to help us to review this as fellows or participants within BioPACIFIC MIP. And really, you'll look at 4 key criteria, which is often used by the NSF, right? One is, how does this align with our MIP mission? One of the key aspects of a MIP is really this knowledge sharing, right? So we really want to build a user facility that accesses the ability to share knowledge. And so that means, like, how does your proposal add to the growth of the knowledge hub or the physical libraries? Of course, then the normal NSF metrics of intellectual merit and broader impacts and diversity is something that is very critical for us. Once it gets cleared, it goes to the execution stage, and so execution stage. And so this is really where you can then get all the forms and policies. We have a user coordinator that is dedicated to help with all logistics, so travel logistics, scheduling. And then for those of you, we just want to make a note that there is funding available to enhance diversity participation, especially for students that are coming from non-R1 institutions or Hispanic serving institutions or HBCUs, right? So please reach out and don't let that be some reason why you're not applying. And so we know that that's very quick. We have then dedicated specifically, you can meet with Alaniz, our user coordinator, Adam and Paul, to talk more specifically about how you can submit a proposal, what are the details, and I encourage you to either reach to them offline or to join the office hours on Tuesday at 2:40, and you can discuss this in person. All right. So now what I wanted to do is just transition and spend the next couple of minutes just describing to you what we have been doing over the last year with building our facility. So as I mentioned, we've been doing this for 1 year, and the goal during this last year is really to build the infrastructure. And we have 5 different areas that we've been focusing on. And so this is advanced synthesis. So you're going to hear about our automated synthetic platforms. This is at UC Santa Barbara. We are also working on automating, as Heather mentioned, the living biofoundry, which will be located at UCLA and CNSI. And so this is some really exciting opportunities. And then to complement this, we have an additive manufacturing suite, as well as structural property characterizations. And then again, really one of the key cornerstones is how do we start to use computation and really this inverse computation design that will be connected with all the high throughput methodology that we're developing so that we can think about using machine learning to connect the structure property relationships that is so critical for moving the field forward. And so just to give you a highlight of exactly what is already available or what will be coming, right? I just want to walk you through some of the cornerstone tools that will be available. And so at UCLA within CNSI, we have already available is the state-of-the-art living biofoundry facility. What the key piece here is what you're looking at is an image of a state-of-the-art automated synthetic biology spinnaker system. This is by Thermo Fisher. And I can tell you by seeing videos of this picture does not do this justice, right? So what you're looking at here is across the middle is a robotic arm that will allow researchers, right, to go from this idea of doing 1 sample per week to greater than 500 samples a week because this entire process is automated. And if you want to learn more about what each of those different modules is within this automated suite, I encourage you to go talk with Michael Lake, right, during office hours. But if you also, right, what we have set up is 3 outstanding talks from industry and academic leaders in the field that really will teach us a little bit more about how we can leverage synthetic biology for material synthesis. And so this is something that I'm excited that you can connect this new tool to potential applications in your own research. At UC Santa Barbara, we've been really focusing on building out the synthetic capabilities. And one of the first tools that is in our synthetic platform or facility, which is at CNSI on the 2nd floor, is this Symphony X. And so the Symphony X is an automated parallel synthesizer that will allow you to synthesize peptoids, peptides, or any other sequence-specific material. And so what's exciting about this tool is that, we really start needing to think about scale. And so here we can have this 24 reaction vessels that can run up to 2 grams per reaction vessel. And so we have an outstanding talk from Euros Protein Technology from Colton Quick, who will talk more about the capabilities of not only the Symphony X, but just in general protein technology. And then if you want to learn about the specific tool that's in BioPACIFIC, you can come to office hours and talk with our project scientist, Dr. Morgan Bates, on Wednesday. To complement this tool, we have also invested in a state-of-the-art Vapourtec flow chemistry system. And so what this will allow researchers to do is really to have continuous synthesis, reactant optimization, and really build through automated platforms our material libraries. This tool is very exciting because it has all the state-of-the-art bells and whistles. And so if you want to run a reaction at high temperature, low temperature, or potentially use electrochemistry or photochemical reactors, that is all possible utilizing this new Vapourtec chemistry suite. In addition, you have the ability to do in situ monitoring using FTIR and NMR, and this will allow us to, again, connect these structure property relationships as we are developing and optimizing these new processes. And then the last, but probably the cornerstone piece of our automated chemistry platform will be arriving in probably about a month, right? This is a new ChemSpeed high throughput robotic platform. This is really going to allow us to automate the entire process to do synthesis of controlled polymerizations that we're all familiar with, such as ATRP, ROMP, and RAFT. You'll allow us to dispense things that are liquids, slurries, solids, and really automate the entire process from reaction and solubility screening, formulation testing, to the actual synthesis and purification. We have a talk from ChemSpeed Bradley Schmidt on Wednesday that will talk real specifically about some of the unique capabilities that will be offered by this tool. And then we have a suite of talks, and that starts right after this talk from Professor Joshua Schreier and others that will really connect what is the power of using high throughput reaction development with material synthesis, and how do we start to think about that. And so the other piece that I want to connect everyone to is, in addition to the synthetic capabilities, both at the synthesis and the synthetic biology side, is we've also been developing a suite of 3D printing technologies. And this is for a range of applications in biomaterials. And so the infrastructure here is also located at UC Santa Barbara, and where the goal here is to use commercially available 3D printers and focus on novel resin design, and then couple that with also new strategies that are being developed by researchers here within BioPACIFIC MIP to use new technology for not only 3D printing, but also resin design. And so again, if you want to learn about these types of details, like what types of printers do we have available that you could come utilize for your research, please visit office hours and talk with our project scientist, Juan Manuel. And then at the end, to round out our summer school, we'll have an exciting talk from Professor Joe DeSimone from Stanford that I think will really connect and resonate with all of us about the power of additive manufacturing and its use in materials. So that gives you a sense of some of the cornerstone pieces of really how we're building out the high throughput automation at both the synthetic biology side and the material side. And now in the next couple of slides, I just want to connect with you that we're also thinking about what are the structural property platforms that we could develop, and how can we use the different high resolution, intermediate scale, as well as rapid analysis for down selection to help us accelerate the discovery of new biomaterials. And so one of the key new tools that we're really excited about that will be estimated to be installed in the fall of 2021 is a state-of-the-art Thermo Fisher microelectron diffractometer, or micro-ED. For those of you who are not as familiar with this relatively newer characterization tool, especially in the materials field, right? I encourage you to come to the talk by Professor Jose Rodriguez from UCLA, who will not only talk about the tool, but really how can we utilize this tool and what are the capabilities that micro-ED offers to material research for characterization and really atomic resolution of some of the building blocks and materials that we're developing. As far as the development side, right, one of the key aspects for us is really connecting the high throughput nature of the synthetic with some of the characterization facilities. And so in order to do that, we have been developing, and by we, I mean Professor Megan Valentine and Professor Matt Helgeson within BioPACIFIC MIP, a high throughput automated microrheology platform. This tool is already complete. It's currently being validated, and it should be ready for external use in the fall. And on Wednesday, they'll give a talk that describes not only the capabilities, but how you can use this tool for microscale volumes of characterizing fluids and soft solids. And so we're really looking forward to their talk to teach us a little bit more about microrheology. And then finally, we will be excited that we are developing a state-of-the-art X-ray scattering facility. This will also be located here at UC Santa Barbara, and this is being led by Dr. Yuli Lee, who is part of our Materials Research Lab X-ray facility. And this is going to be one of the most state-of-the-art X-ray scattering tools in the country outside of a synchrotron, and it really will increase the resolution compared to our current in-house SAXS facility here at UCSB, but also increase the resolution compared to many of the facilities that are around the country. And so in addition to characterization, right, we also recognize that computational tools are going to be key. And so we are also investing in computational tools to connect the chemistry, the structure, and the property functions. And so we'll have an outstanding talk that's being led by Professor Scott Schell, who is leading this effort on Wednesday. But we also have really outstanding talks from leaders in the field where we can start to think about how can we leverage all the big data that's coming out of this, right? And so Professor Brad Olson will talk about how do we start to utilize the data in a constructive way, and then also connecting this high throughput nature with machine learning, right? We have an outstanding talk from Professor Alan Aspuro-Guzik on Thursday morning. And so I know that that's, not a lot of detail on these tools. I just wanted to introduce them to you for sake of time and really more encourage you to see that all of the talks during this summer school are intertwined so that we can all learn more how we could potentially use these tools to advance our research. And if you want to spend any time learning more about the specific tools, I encourage you to go to office hours and meet with our project scientists or connect with them offline. And so the last slide that I want to talk about is really just to speak directly to the graduate students, postdocs, and undergrads. And BioPACIFIC MIP is really dedicated to training, networking, and mentorship, right? All of this geared towards workforce development. And so we have established a BioPACIFIC MIP Fellows and BioPACIFIC MIP Associates. And if you want to learn more about this, you can complete this interest form by clicking on this QR code. This information is also on our website, but this will just allow you to then participate in things outside of the summer school. Throughout the year, we have different types of career development talks, networking opportunities, and just aspects that I think will be relevant for graduate students of how to transition from, your PhD onto a career in STEM once you leave your doctoral work. And so within the summer school, I just want to highlight that we have a series of professional development events. The two that are highlighted, we have the career panels, an outstanding one on Tuesday and another one on Thursday with leaders from industry, many of whom are giving talks during this summer school. I encourage you to join these career panels and hear some of their great advice. And then those of you, we also have, as I mentioned, smaller professional development programs that are specifically for the graduate students. These are closed events, but these are really exciting to start to introduce you to things like how do you use your individual development plan? How is that used in industry? And why is it important to start to recognize that now in your early careers? And so with that, I will stop and take any questions and from anybody that might have them. And if we don't, I'll look at the chat. Not sure if we can stop sharing.